Hello everyone. So today we're going to look at three different topics. The first one is going to be really quick. Um, so we're going to look at the date class. So the date class, you can use that to retrieve or basically get the current system time. I'll show you a quick example. So uh, So we use the date class provided by the Java API for that. And I'm going to do is I'm going to declare two date objects, D0 and D1. Y2, you'll see in a minute. So got that. And let's say now this was just the declaration. Next is creating first date object. I call the constructor of the date class, and let's say basically let's use the date class to measure how fast some code that we write executes. Okay, so code begins over here, code and anything that I write in between these two comments, we're going to measure the time it takes to execute that. So after whatever code I've written in there finishes running, I'm going to create the second date object. So D0 will contain the time and date at which this line executes, and D1 will contain the date and time when I'm creating the second date object, and then maybe at the end I'm going to print these out. So print line, and first one is going to be start time, and the date class comes with a very handy toString method, which will take the information contained inside the date object and it'll convert it to a human readable string, nicely formatted and all. Okay, and so this is the start time, and just like that, let's also print out the end time at which the code ended execution. And just to demonstrate one more thing, so let's say we also want to know what the time difference between the time in D0 and the time in D1 is. So what I can also do is I can use D1 dot get time. So get time is another method of the date class, minus start time, D0 dot get time. So D1 dot get time minus D0 dot get time. This is the time difference between these two date objects in milliseconds. So milliseconds. I'll explain what the getTime method does. Let me show you what this looks like when we run this. There you go. So code started executing on Monday, today, October 1st, 3:58 p.m. I think that's Arabian Standard Time, 2018. So AST, that's the time zone that we're in. Okay. And 0, T1, yeah. Start time and time, yeah. There you go. Okay. So there's one other thing that you have to understand. So question is if so the get time method converts the date contained inside the date object, converts it into milliseconds. Question is, what is time zero? When is from what date do we start counting? Um, so this particular time, this is also, there's another name for it. It's also called Unix time, and time zero for computers um, measured in milliseconds is this date mentioned on the slide, January 1st, 1970, Greenwich Mean Standard Time. So this moment in time, January 1st, midnight, January 1st, 1970, this is considered time zero for computers. When you call get time, let me demonstrate that as well. If you call start time and Unix or computer time, call that anything. Let's print that out as well. D0 dot get time. There you go. Just let's do the same thing for the end time. There you go. That's going to be D1 dot get time. Okay, let's print that out. So this is, run this. There you go. Okay. So this date that you see over here, this date and time, is exactly this many milliseconds since January 1st of 1970. And yeah, for the moment, that's about all we need to know about the date about the Java API's date class. The second thing I want to talk about is random number generation. Now we've already done that several times, um, so I'm actually not going to write any code about that. I'm just briefly going to point you to this slide 42 in the lecture set that's already uploaded, and so you can see we have a UML class diagram over here. So you know that we've already been using the the random method in the random class. Um, we have been using um, uh, math.random's ability to generate numbers between 0 and 1, and then what we were doing was we were scaling them up to whatever range we needed them to be in. But the random class, the random class, which is also in java.util, gives us a bunch of other methods. So, for example, if all you want is an integer, you can just call nextInt as a method, and that will also give you an integer. If you want those integers to be restricted to a certain range, let's say integers between 0 and n, where n is not included, you can call nextInt, the nextInt method of the random class, with n as an argument. Just like that, I can generate random numbers, random long values, random double values, random floating point values, and random Boolean values using the next long, next double, next float, and next Boolean methods. So I'm not going to do any example for this because we've done plenty of that. Some of you actually, instead of using the math.random method, were already using the java.util.Random class, and that's perfectly fine. It was actually good to see. So this was the second topic I just wanted to point you to. Make sure you know these methods, try them out. And I want to move on to something I already alluded to in last lecture, and that is the use of the static keyword and what that does. Okay, so now um, the static keyword has different effects on whether you put it in front of a variable, or whether you declare a variable static, whether you declare a method static, and then we also have something called final variables. Um, so let me show you uh, what that does. So the first one, uh, we already you're already familiar with at least one of these, declaring a method as static. Uh, and in short, and we already covered this, but what basically happens is if you declare a method static, uh, it does not, you do not need to create an object of that class in or before calling that particular method. And the prime example of that is the main method in every project that we've made so far. You can see by default the main method is already declared static, and that's basically why we can that's why our program can start executing from the start of the main method without first having to create an object of the class that contains this main method. So not so much new, but the new thing that we're going to try out, and for which I'm going to show you an example, is um, what happens when you declare a variable static. And that's kind of interesting. And, so let's go back to our project, and the code that we're going to write uh, for, for trying out for using static variables. Um, the whole thing, I'm just going to put that here between in this section, and at the end of that we can actually will also be able to see, this will also print out the time it took us to execute that whole the time it took to run the whole project. Okay, so it's basically this example will serve as a 2-in-1 example. So the example that we're going to do is going to be one of a class that has a static variable, something we haven't done yet. So first of all, let me add a new class to the project we're working on. So by now I should know how that works. So right click on the package, new class. So call this one student. There you go. And this class is going to contain the name of the student, age of the student, and going to get into the habit of sorry, not public. Let's make these private, and we're going to have more than just one student object, kind of like having students in a class. Um, so I'm going to have a static, sorry. So I'm going to have a third member variable, this one called class size, and it's going to be initialized to 0. Um, don't even have to initialize it, and going to have a bunch of member methods. So a public constructor for the student class. Let's have a no-arg constructor. I'll get back to this. I'm going to have another constructor, one that takes a string and an integer, so basically name and age as argument. It's going to assign the name to string n to the name, and it's going to assign the integer a to the age. Okay, and there's something else I'll come back to over here. Let me add, just as a matter of routine, let me add some methods that allow us to read and write the age and name fields of the student object. So let's say we have a set name method which takes a string and assigns it to the object's name. We have a set age method which takes an integer and assigns it to the object's age member variable, and correspondingly we're going to have a get name method which doesn't take any argument but returns the name of the student object. Similarly, another public method which returns, called getAge, which returns the age of age contained in the student object, and looks like we're almost done. So coming back to this, oh yeah, one other thing. So we still have this class size member variable, okay, and this is going to keep track of how many student objects have already been created, which means every time a student object is created, every time a student constructor is called, the value in class size should increase by 1. And the most elegant way to do that is this. You could also write class size equal to class size plus 1, or class size plus equal to 1, but this is most elegant form of incrementing an integer by 1. So we're going to do that. And also going to read, I'm sorry, oops, where did that go? Yeah. I'm also going to read the value of class size, so we want an accessor method for that. A public static method that returns an integer, and name of the method is getClassSize. GetClassSize, and returns the class size member variable. Okay, looks like our student class is ready. Time to try it out. Okay, let's go back to the main method. And the first thing I'm going to do here is going to create a student object S1, and just for fun I'm going to create a student object S1, and after I do that, so S1 created, I'm going to print that out so we know in the output where we are, what's going on. Okay, and then I'm going to print out S1 class size, so the value of class size. Okay, so and I can access that using S1 dot get class size, get class size method, the last one that I just made. Okay. So at this point, we will have only a single student object. Not very interesting. I'm going to create a second student object S2. This is going to, the name of the student is going to be Bilal. He's going to be 21 years of age. And so S2 will have been created at this point, and I'm going to print out the value returned by get class size of student object S2. And not only that, I'm also right here, I'm also going to print out the value returned by get class size of object S1, just to compare the two. Okay, so what are we expecting to see? We're expecting to see over here class size after the first object is created, its constructor, this one, will increase the value of class size member variable from 0 to 1, right? Show you here. It's the last thing that we do in the student constructor that takes 2 arguments, which is the one that we're using. By the way, the same thing happens in the no argument constructor. Okay, all right. Then when we create the second student object, because the class size member variable is shared by all student objects, it's the same variable, shared by by S1 and S2, it's going to be incremented again in this constructor. So we expect get class size to return the value 2. And if we try to access, if we call get class size of object S1, we also expect to see the value 2. And just for fun, I'm also going to use the other constructor, the noarg constructor, and I'm going to create a third object. And so create S3, and for this I'm going to print out the value of class size that I get when I call get class size for objects S3, S2, and S1. Okay, and just to make sure we use all the other methods that we made, I'm also going to call the set name and set age methods over here. And this guy's age is going to be 24. It's going to be an old student. Okay. So before we run this, take a minute to think about what we expect to see from this program in this range, and just to make the output look nice, put in a blank line over here, put in a blank line over here, and put in a blank line over here. Okay. All right. So I think this will make the output look a little nicer. Okay. So we expect to see class size to be 1 here, 2 over here, 2 over here, 3 over here, 3 over here, and 3 over here. Let's run it. Let's see if that is the case. There you go. So S1 was created, class size was 1. I made student object S2, class size, when we call get class size for object S2, the value returned is 2. But when we call get class size for object S1, the value is also 2. And when we create the third object, value of class size becomes 3, whether we call it for object S3 or S2 or S1, because it's the same variable shared by all three student objects. And here at the bottom, take a look. So this code started running at this time, ended at this time, and the time difference between these two timestamps is 5 milliseconds. So it took 5 milliseconds to run this program from here, after we created the date object D0, to here, when we created the second date object D1. Take a look in your slides. There's a visual explanation of what happens, or of how static variables work. So in this one, there's this class circle. You can see that in this UML class diagram of this circle class, number of objects, an integer, is underlined. I should mention this is something new. Whenever any member variable or member method of a class in a UML class diagram is underlined, it means that variable or that method is static. And over here, number of objects is a member variable that is declared static. And as you can see in the visual diagram, we have two objects of class circle, circle 1 and circle 2. The number of objects variable between these two objects is shared in memory. It's the same variable. Take a look at this example. This is very similar to the student example that we just did. Okay, you can try running this. We've also demonstrated the use of public and private visibility modifiers. There's a simple explanatory example in the slides. Take a look at that, but we've definitely kind of done more than that already. So why declare anything private? There's a couple of points here. The key term to remember is information hiding. So we do this to protect data, to make classes easy to maintain, to prevent parts of our code from accidentally overwriting the values of member variables of another class. Another word for that is encapsulation. And here is another thing that another new thing should know about UML class diagrams. You can see in this UML class diagram of the class circle that the member methods that we see down here, they all have plus signs in front of them. The member variables over here, radius and number of objects, they both have minus signs in front of them. This is not by accident. That actually means something. A plus sign means that whether variable or method, plus sign means public. The minus sign over here means private. Okay, so this is it for today. I'll see you tomorrow with a new task in class, with a new programming task. I think we'll wrap up this lecture set by the end of this week. So I'll see you all in class.